We'll proceed in vector, algebra, and calculus. Vector, algebra, and calculus. You are amazing. You are awesome. What is the speciality of vector? Vector has magnitude and vector has direction. Are you not talking about energy? Energy also had magnitude and energy has a direction. Certainly. Vector represents energy. What is calculus? Calculus is nothing a way to calculate the addition. What is multiplication? A way to calculate the addition. Okay, you mean addition can be calculated through multiplication? True. Multiplication is nothing but repeated addition only. Okay, if that is true, then what is calculus? Calculus means integral calculus. That is primitive calculus, old calculus. Then what is calculus? Then calculus is also a way to calculate the addition only. If multiplication is there to calculate the addition, then integral calculus is also a way to calculate the addition. Addition, multiplication is a way to calculate the addition. Calculus is a way to calculate the addition. Okay, net idea is to have the addition. One is through multiplication, one is through calculus. Calculus also calculate the addition only. Okay, how multiplication does the addition? It multiply two items and there is a norm, there is a protocol for it. What about calculus? Calculus, when we give multiplication of two items, then one item it consider x-axis and other item it considers y-axis and it draw a graph and it calculate the area. Whatever the area comes, that is the net addition. That is integral calculus. Okay. Now tell me other definition of integral calculus. There is no more definition of integral calculus. Integral calculus means addition of two items. I mean, okay, if I said multiplication, like, okay, someone can say extension of multiplication, like 4, 4, 4, 4, 4, 4, 4, 5 times. We can also write 4 into 5. Okay, so 4, 5 times, that is the addition. I can write 4 into 5. 4 into 5 is what we are looking for. Other is 4 5 times, means you draw x-axis, there it is 4, 5 times, right? Then draw y-axis, it is 5. It will form a rectangle. X-axis is 4, y-axis is 5. It will draw a rectangle whose side is 4 and another side is 5. Calculate the area of this rectangle. Area, as I always say, area of a rectangle is not 4 into 5. The way we think that area one side of the rectangle is 4 and other side of the rectangle is 5. So area is 4 into 5. Not true. The area of the rectangle is, take a small square. Take a square whose one side is 1, another side is 1. Square. Now place that square in this rectangle. Now count it how many they are. That is the area of the rectangle. So area of the rectangle is actually like this. So that is like this. If someone goes with multiplication, then area of any shape, not only rectangle, can be called width into height, is the area of any shape. Area of a rectangle is also width into height. 4 into 5 is the area of the rectangle if I talk in multiplication way. But the actual way of the calculating the area of rectangle is take a small sub-rectangle of height 1, width 1 and keep there in the rectangle. Now count it how many they are. That is the area of the rectangle. Okay, other people say just multiply width and height. But the area of them, what is integral calculus? Integral calculus takes one square sub-rectangle, places there and it counts it. That is integral calculus. This is the way it is calculating the net addition. Multiplication, simple multiplication. Integral calculus, calculating the area of a shape, is the net addition. Okay. Now, question is arising that consider that I have Now I am saying 4. I have 4, 4, 4, 4, 4, 4, 4, 5 times. Then that is the addition I am looking for. Now I am looking for addition 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 1000. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to 1000. Multiplication cannot do it. Not possible. Multiplication cannot do it. Then you are only at the mercy of calculus, integral calculus, to calculate the net addition. Mind it. Okay, I believe there are formula also, right? If there is n, then n into n minus 1 by 2. I think so. Like 1 plus 2 plus 3 plus 4. That will come as 10. 6, 10. That is n into n minus 1 by 2. 4 into 3 by 2. Not true. Okay. 4 n into n plus 1 by 2. I believe it is all right. Now 4 into 5 by 4 into 5 by 2. 10. So n into n plus 2 by 2 is also the net addition if it is 1, 2, 3, 4. 1, 2, 3, 4 into 1000. That is 1000 into 1001 divided by 2. This is what I think so. Then it will come 1001 into 500. That is nothing but 1000 into 500 plus 1 into 500. Now it is simple. Anyway, but it is not generic. It is only for one series. Or if it is 1 up to 1000, then 1 into 5, 1 up to 10,000, then 10,000 into 1. That is multiplication, through which that also we can calculate the addition. But calculus, you are amazing, you are awesome. Calculus says, why you are in this much pain? X-axis collection. Okay, you are saying 1 plus 2 plus 3 plus 4. Now consider every time you are getting some number. First second you got 1. Second you got 2. Third second you got 3. Any amount. Then at the end, in 10,000 second, you got 10,000. That is it, right? So this is x-axis. This is 0 second, 1 second, 2 second, 3 second, up to 10,000. 0 second, nothing. 1 second, 1, 2 second, 2, 3 second, 3, 4 second, 4. Like, then it makes a shape, right? Now, the integral calculus calculates the addition, but it draws a graph. That is the fundamental of integral calculus. It draws a graph. Now, graph is a triangle. Can you see? Now, it will calculate the addition by calculating the area of a triangle. What is area of a triangle? Okay, what is equation of this line? Because now integral calculus would jump into algebra. Now it will say, okay, what is the area of any shape? Width into height. Width into height. Width into height is area of something. If that is true, width into height is area of something, then area of this triangular shape is also width into height, but that is not true. Width into height is not the area of the triangle, but area of anything. What integral calculus is say, we follow multiplication. If you give me, a repeated addition, then I consider one. I take two axes in that. One is independent component, one is dependent component. This is what algebraic calculus says. So independent component is time, and dependent component is net collection over a period of time. If that is true, then like if someone is collecting 10 times, 2 into 10, width 10 times, then this width is 10 times, and height is 2. Then net area is 2 into 10. Calculus is also say it is 2 into 10. Okay, so what is the height? Height is 2 fixed. What is the width? 10. It can be x, any x. 2 into x is the net area. What calculus is saying, it is not guaranteed that it will always be multiplication. Like in this case, when someone is collecting and first second 1, second 2, in that 10,000 second 10,000. In that sense, this graph is not a like this. Graph is like this, triangular. So So equation of this is x. If this is time, then whatever is collection is x. At the in 500 second, the net collection at that moment is 500. So this is called x. Now it is saying integral calculus saying indeed area is width into height, but height is variable here. It is not constant height that I can make rectangle, but still it is saying that area is nothing but multiplication into height, multiplication of width into height. Now it rephrases it and it says height into width is the area. What is height? Height is function over x, that is x. What is width at any x we want? So x into x. Since that is not true, so second x it places d there, x into dx. This is called abstract multiplication. So someone would ask, is it the integral calculus? Integral calculus is abstract multiplication? Yes. Integral calculus is width, height into width only, but it is abstract multiplication. At the beginning, it looks like multiplication, but it goes beyond it. That is abstraction, right? Abstraction, if we see in designing concept, whatever we see behind the scene and whatever is interfacing the customer, okay, whatever it is interfacing the customer, it will be same. Okay, like I have to pay electricity bill, I have to pay water bill, I have to pay this bill, I have to pay that bill, I have to pay this bill. There are 500 bill I have to settle down. Now for every bill, now if I am going to some ATM machine where I can pay the bill, now I select electricity bill, then I understand the full format, then I fill it, then okay, then I go for water bill, completely different architecture. Then I fill here and there, fill the address and this and that, and then I said okay, if 500 item if I start doing like this, certainly I would die. Now rather than that, there will be one interface only, one in same graphics. Okay, just just select what you want, electricity bill amount. Okay, interface is same, but behind the scene scenarios are different, because the software that is tackling the electricity bill, it is going, all the money, all the inventory is going to the other area. Interface is same. Like that, if I say that addition repeat, if I have more addition, then that is multiplication, if I say like that. But that is for repeated addition only, 2 plus 2 plus 2, not 1 plus 2 plus 3 is the multiplication. But integral calculus say it is multiplication only. Don't worry. Okay, now what I have to do is I'll take one x-axis and y-axis, and I say your end result is y-axis into x, y into x. Y is fx, function over x. Here it is x because it is a triangle x. X into x, that is x-axis. Now that is x-axis, instead of saying x into x, it places d there, x into dx, claiming this is abstract multiplication. It looks multiplication, but it is abstract multiplication. Now, if you want, now you want x into dx. Now, as per the integral calculus, x dx is x square by 2. So, net addition is x square by 2. Okay, if that is the case, x square by 2, then 1 plus 2 plus 3 plus 10,000 is 10,000 square by 2. There is a gotcha of 1 that someone can settle it down. I don't think it is a big issue. So that is the scenario. Probably we have taken 0 to 10,000 as a limit or something like that. Okay, so that is, but it is more or less same, right? It is some matter of what limit we are taking. Okay, so it is x square by 2, or because of discrete nature, it is not highly continuous, but whatever it is x square, it is x square by 2. Okay, so this is integral calculus. Integral calculus says that whatever multiplication, whatever you want, whatever addition you want, think about multiplication, think about two components, and then multiply it. But it will be abstract multiplication, and then you get the result. Okay, now we are in phase of finding the curve length. We are in phase of finding the curve length. So what is vector analysis says? If you want length of any line, if you want length of any line, what is the length of this line? First represent it through vector. Represent it through vector. Then get the magnitude. That is the length of the line. Hope, hope, hope. Makes sense, right? If I have a line, the equation of the line is y equal to x. Y equal to x. If this is the x-axis, then this is the y equal to x at 45 degree. Y equal to x. Now I have a line along y-x equal to x line that connects point 0, comma 0 to 4, comma 4. What is length of this line 0, comma 0 to 4, comma 4? Or I can just say I have a point 0, comma 0 and 4, comma 4. What is the length of this line connecting this line? What is the equation of line? Y equal to x. That is the equation of line. What is the equation of vector along this line? Y equal to x. Now, please watch previous two videos. If you want vector notation of any curve, vector representation of any curve, first try to get position vector of any point on the line. Then differentiate it. That is the vector along the curve. What is the vector along this curve? That is tangential vector that is along the curve. If this is position vector, if I take any point on the circle, and this is the center, it is centered at the origin, then this is the position vector. If I calculate derivative of this vector, then this is the tangential vector. This is the vector also I can also call curve vector. This is the vector I can also call curve vector or vector that is tangential to the curve. If I have a line like this and I want to, that is y plus x equal to this is what always I am considering. Or consider y equal to x is the line. If this is the line, if I take any position vector, the position vector will be along the line only. Let's consider a line y plus x equal to 3. This is what I have been taking. Y, this is x-axis, this is y-axis, this is x-axis, this is y-axis. In that case, there is a line. If this is x-axis, this is y-axis. There is a line like this. Equation of the line is y plus x equal to 3. Y equal to 3 minus x. What is the distance from, it is 3, comma 0. It is 0, comma 3. What is distance between these? Someone would just say, what is distance between 0, comma 3, sorry, 3, comma 0 to 0, comma 3? What is the distance between these two? What is the equation of the line? Y plus x equal to 3. What is the vector? Now consider, if consider this is, consider, okay, now consider, now this is the line. Okay, now if I take any point P on the line and I draw position vector, and if I differentiate the position vector, then new vector will come that will be along the line. That is what we want. A vector along the line or tangential vector along the line. If this is the line, then tangential vector will be along the line only. What is the point there? Any point if I take position vector xi plus yj. What is derivative of it is I plus dy by dxj. I plus dy by dxj. If that is the case, I plus dy by dxj, y equal to 3 minus x, dy by dx is minus 1. Then the equation of the vector is I minus j. I minus j. Okay, what is the magnitude of this vector is? That is the length of the line from 3, comma 0 to 0, comma 3. Makes sense, right? This is what we are saying. We are saying that first, if you have a, if I want distance between 3, comma 0 to 0, comma 3, 3, comma 0 to 0, comma 3. Distance between these 2 points is nothing but first I have to find the equation of the line, that is y equal to y plus x equal to 3. What is the vector notation? Take any position vector x, comma y, xi plus yj, differentiate it. The new vector that will come, that will be tangential to the curve at point x, comma y. Tangential to the any curve, that is the line, any point, any x, comma point will be along the line only. If that is the case, then it is I minus j. Calculate the magnitude of the I minus j. Then it is the square root of 2. A square root of 2 is the distance from 3 comma 0 to 0 comma 3. Not true. Square root 2 of 2 is not the distance from 3 comma 0 to 0 comma 3. Distance is more. Okay, what mistake I did? I said the vector equation, the vector notation for line x plus y equal to 3 is I minus j. It has x component, it has y component. X component is 1, y component is minus 1. Where the point we want, if this is x axis and this is y axis, it is 0 to 3. 0 to 3. So we want x component to be 3. Here x component is 1. So whatever is the magnitude of vector I minus j, if x component is 1, we want x component 3. Multiply by 3. So the length of the vector I minus j is square root of 2. Then the net length is 3 into a square root of 2. What is the length of the line? What is the length of the line that connects that connects any point x comma 0 to 0 comma x comma 0 to 0 comma x? Vector will be same I minus j, but direction is same. Then magnitude is square root of 2. Then the square root of 2 is the magnitude for the vector whose x component is 1. If x component is x, then net length of the line is x square root of 2. This is primitive calculus. Primitive calculus says whenever you are trying to get length means you are adding one unit. That is the length. What is the area? What is the length? Length is if I have 1 unit length, if I take 1 unit length thread, then just measure it how many they are. That is the length of the curve. If you are trying to calculate anything, okay, then try to get in fx and x, y-axis and x-axis. This is what it says. Or if you have any ready-made multiplication, then denote give the notation of the multiplication. Multiplication has two items, right? One is independent and one is dependent. Dependent is fx and independent is x. Instead of x, write it as dx. Now multiply it. Now from which location to which location you what? Place as limit. This is primitive calculus. So when we are trying to calculate the length of a vector, then it is for duration of 0 to x. Then if I have any vector p, calculate the magnitude of the p, but make sure that p's x component is 1. If it is 1, then calculate the magnitude and it multiply it by x. Then you get the net length of the vector. Okay, it was very straightforward when it was a straight line. What about this curve? For this curve, what is position vector? Xi plus yj. What is the line along the curve? Then differentiation of the position vector. That is I plus dy by dxj. Whatever comes, i's x component is 1. So it will satisfy our need. Calculate the magnitude of this vector. That is the magnitude of the vector at any point x comma y, which is vary because it is not a straight line. See, the curve vector is varying at every point. But anyway, at any point x comma y, what is the magnitude of the vector? This is what we have seen, right? And make sure that its x component is 1. Now you want for some x component, right? The net length of the curve at any point x comma y is something. That is for x equal to 1. For 0 to x, multiply it by x. So what is the magnitude of dp by dx? That is I plus dy by dxj, which I has component as 1 and it is the curve vector. Curve vector, if you have curve vector, means you are representing your curve as a vector. That is vector field algebraic vector because its components are vector. So if position vector is xi plus yj, any point is x comma y is position vector is xi plus yj, then curve vector is dp by dx, that is I plus dy by dxj. If that is the case, then it is really curve vector because whatever the position vector, whatever we are seeing, that is perpendicular to the curve any moment. If I have getting dp by dx another vector, if these two are perpendicular again, the new vector is like along the curve. Makes sense, right? If I have a circle and if I take radius, the radius is perpendicular to the circle any moment. If I have another vector that is perpendicular to this, then enemy is friend, right? In that case, then another vector is along the line. Makes sense, right? If I have a radius, at any moment radius is perpendicular to the arc. Any moment radius is perpendicular to the arc. If I find a vector that is perpendicular to this, then that vector represents the arc. That is algebra. Makes sense, right? Like dp by dx, if p is xi plus yj, dp by dx is I have already covered this, I plus dy by dx, j. Y is square root of a square minus x square for the circle. Then dy by dx is minus xy square root of a square minus x square. That is minus xyy. So xi plus yj dot with I minus xyj will be x minus x, 0. This proves that indeed both p vector and dp by dx are orthogonal to each other. Means dp by dx is a curve vector. If I have a curve, how we calculated the length of a line? You get the vector along the line and make sure the ith component is 1. Get the magnitude and multiply by for how long distance we want in x. So here the ith component is 1 I plus dy by dxj. Now it is I minus xy square root of a square minus x square j. What is the magnitude of this? Magnitude of this is a by square root of a square minus x square. Hold it. This is the magnitude of the curve vector at any point x comma y. Okay, but I want any point x comma y for ith component is 1 for one unit, for 1 unit. 1 unit can be 1 centimeter, 1 millimeter, anything. Now I want from 0 to x, any x, then multiply it by x. Then it becomes a by a square root of a square minus x square into x. What is x? X is x-axis, independent component. What is this? Function over this is a by a square root of a square minus x square is dependent component. Why it is dependent component? Anyone would ask why it is dependent component. It is dependent component because a square root of a square minus x square term came because of y only. Y equal to square root of a square minus x square. If I see the beginning vector, p vector is xi plus yj. Y is a dependent component. Xi plus yj both are not independent. X is independent. Y is dependent upon x. That's why y equal to square root of a square minus x square. So net magnitude, what we are saying, a by a square root of a square minus x square. The term came from the position vector p in the yth component. Yth component is dependent. Means this net magnitude is dependent component. So if I need to calculate multiplication for the dependent and independent component rather than a by a square root of a square minus x square into x, next x, the last x, that is independent component x-axis, it becomes dx. Then if it becomes dx, then what will happen to 0 to x? We are trying to calculate the net length. That will come as a limit. This is the integral calculus. Whatever the x we are thinking 0 to x, that becomes a limit. 0 to x, fx dx. Fx is the dependent component and x that turned into dx, that is the independent component. This is primitive way of calculating the curve length. What is a new way? New way. What is the new way talks about calculating the anything? Okay, what new way talks is if I want to calculate the kind of integration, if I want to calculate the integration, if I have x-axis, and this is the curve, I want to calculate the integration. Integration is indeed the area calculation only. This is what new approach is also saying. But what it says is that take any at any point x, take any delta x distance. Here this is the delta x distance. Any point x, this is the height. If I take delta x here, then there is one rectangular strip comes into the picture. How come you can say rectangular? Base is flat, I agree. Height is flat, I agree. But top is not flat. Top is not flat, it is circular. But since delta is so small, I consider this is at a rectangle only. This is the new way. Now, since you calculated area of one strip, now like that, make infinite strip and add it. That is the integration, right? You make 1 billion of the strip from from here to here. If you are trying to calculate area, make 1 billion strip. Each strip is an width into height, width into height, width into height. Height is varying, right? If I go distance by distance, height is keep on varying. So their area will change, width into height. Now calculate the all the area, it becomes the net integration, that is from 0 to x. This is new way. We will go by new way. So new way, we are in new way. We now think that if this is, now we are trying to calculate for the circle, right? New approach, new approach in calculating the vector length. This is what we are talking. Now this is a circle. Now at any point x, what is the height fx? That is the height at any point x. Now at any point x plus delta x, what is the height? F x plus delta x is the height. That is also called y. So if I take this point, this is x comma y or x comma fx. If I take another point, then it is x comma fx plus delta x. This, I'm sorry, first point is x comma fx, x comma y. Another point is x plus delta x comma fx plus delta x. If I connect these 2 points, then it makes a vector. Makes a vector. It makes a vector. Okay. If it makes a vector, what is the equation of the vector? What is the vector? Now, if you see minutely, then this is the x-axis. On x-axis, at any point x, this is origin. This is center is the origin. At any point x, this is the height. At any point x plus delta x, this is the new height. At any point x, if talk about this point, this is x comma y. At any point x plus delta x, this is the new point, that is x plus delta x comma new y. So here it is x comma fx and it is x plus delta x comma fx plus delta x. If I connect these 2 points, it becomes a vector. That vector is x plus delta x minus xi plus fx plus fx plus delta x minus fx j. That is the vector. What is the length of this vector? So x plus delta x minus x is delta x. Delta xi, delta xi, delta xi plus fx plus delta x minus fx j. What is length of this vector? If consider that this delta x is very small, very small. If delta x is big, then it will form a line connecting an arc. If delta x is very small, at that moment it will be tangential. It won't become underneath it. It will be tangential at that point. If delta x is very small, whatever it is. Now I can rewrite it. Now the vector equation is delta xi plus fx plus delta x minus fx j. I can represent it divide by delta x into delta x. Possible, right? This is divide by delta x into delta. If I don't divide and try to calculate the magnitude of this vector, length of this vector, where the x-axis is delta x, length of this vector is delta x whole square plus fx plus delta x minus fx whole square root. Wow! I found the length of the vector between any 2 points. One point is x and another point is delta x. For the delta x width, I found the vector length. That vector length is delta x whole square plus fx plus delta x minus fx whole square root. Since I got for one vector, if I divide delta x is the one division, if I divide into billions, then all the vector if length if I add, it becomes the full vector length, that is the arc length, right? That is the length of the curve. Makes sense, right? Okay, very nice. Thank you. Let's go beyond it. This is the new approach. No approach is available in the book. What book talks, that we will talk later. Okay, so Please do support us. Okay, it helps us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. This proof is not available anywhere else. None of the proof is available anywhere else. Now, what is the length of the curve we found? What is the vector we found? Delta xi plus fx plus delta x minus fxj. Okay, now let's divide it by delta x and multiply it by delta x. We can do, right? Now it becomes I plus fx plus delta x minus fx by delta xj. Through the first principle, fx plus delta x minus fx by delta x is nothing but dy by dx only, dfx by dx, dfx by dx, that is fx plus delta x minus fx by delta x, that is dy by dx, dfx by dx. So I plus dfx by dx j into delta x. Consider this is the I divided it into infinite section. If I take from 0 to x, any x, I divided into infinite section. That is the ith section. Ith section. So I can say our vector representation is nothing but I plus dfx by dx j multiplied by delta x, ith delta x. That delta x is so many. Now, if I calculate the magnitude of this vector, same vector, magnitude of this vector, this is 1 square plus dy by dx whole square root into delta x. Because delta x, if I take inside also, it will come out. So del 1 square root of 1 square plus dy by dx whole square and then delta x. This is the length of the vector for any small delta x ith unit. If I want full length of the curve, this is, since delta x tends to 0, it talks about the length of the section. How come it can be the length of the section? If I take one point here and one point here, what the line we are talking the in form of vector is this line. This line length is 1 square plus dy by dx whole square root into delta x. But we want this line, delta x tends to 0. Since delta x tends to 0, this line we can consider as tangential only. Because delta is very small, so it is tangential only. It satisfies, right? Tangential line is the curve line. If I get the tangential vector length, that is the curve length. So for delta x reason, I got the curve length. If delta x are too many, if I add all the curve length, it becomes the net curve length. So I have to now add now I have to add 1 square plus dy by dx when x is at the first delta x whole square root into delta x first delta x. From origin, I have 1 billion delta x, first delta x, second delta x, third delta x, fourth delta x, plus square root of 1 square plus dy by dx whole square, where x is at next delta x is x plus delta x into delta x second delta x. Like that, if I start keep adding dy by dx, but dy by dx is algebra, right? So I may not denote it as first, second, third. So 1 square plus dy by dx whole square root. Now delta x1, delta x2, delta x. If I take this out or if I add completely, then it becomes delta x would become dx. If that is the case, then it will be represented as square root of 1 square plus dy by dx whole square, 1 square plus dy by dx whole square root dx. And now 0 to x we were calculating, it becomes integration 0 to x. This is new calculus where delta x tends to 0 and you try to calculate for one subsection. Now add it. If you add all the delta x, if you add in summation form, it becomes dx and dx, and one snake sign will come, integration 0 to x. This is new way of calculus, but at the end we are reaching to the same solution. 1 plus dy by dx, 1 plus dy by dx is minus x by square root of a square minus x square. If you settle it down, a by square root of a square minus x square into dx and then 0 to x. So if I want for first quarter, circle has 4 quarters, first, second, third, fourth. For the first quarter, then x is from 0 to a. 0 to a a by a square root of a square minus x square dx would give the curve length of the first quarter. Multiply it by 4, it becomes 2 pi a. That is the length of the curve through new calculus. Old calculus we saw. Old calculus, you calculate you try to bring into multiplication form. And in multiplication, one is fx, one is y-axis, and one is x-axis. Instead of x-axis, place there dx. And from where to where you were calculating, place it as limit. Fx dx limit. New fundamental is take any delta x and calculate whatever you want. Now add it. Consider delta x like delta x subsections are infinite. For one delta x, you calculate whatever you want. Now add it. Okay, and bring it into calculus form because delta x too many, it will become dx integration 0 to x. This is a new way of calculus. So both way we saw, and it is 2 pi a. We will proceed on this line curve probably one more session, and then we'll see what we need to cover. Amazing, mind blowing. So please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country.